Hey, what's up, guys? Hope all of you are safe and healthy. I am back again with part 12 of AWS Lambda video series. And in this video, we are going to discuss few more additional points about AWS Lambda. The first one is setting up the additional concurrency limit for AWS Lambda. Secondly, asynchronous invocation feature of AWS Lambda and connecting a file system to AWS Lambda. Okay, so let us jump on the AWS Lambda console and we'll explore all these 3 points one by one. Okay, so I'm on my AWS Lambda console itself. Okay, and let us understand is what is this concurrency limit itself. Concurrency limit is the limit that defines like a particular Lambda function or Lambda functions how many concurrent executions are a Lambda functions can make. Okay, that is all about concurrency, right? So in production environment, if you are leveraging Lambda function to create some utility or some running some script on the production environment, definitely there will be a scenario, there will be need like a function is serving more than one request at a time. Okay, so multiple concurrent executions of the Lambda function is needed. Okay, so in order to increase that limit, because definitely in the production we would need the higher concurrency. Okay, and in order to increase that concurrency limit, we need to log into the service quota dashboard, and there we can make request to AWS support team to increase the concurrency limit. Okay, so I'll show you how we can create the request to increase the this concurrency limit. One more important thing, whatever limit is allocated to the Lambda functions, okay, that is on the account level. As you can see on the account level, I have concurrency limit of 10. Okay, and this 10 concurrency limit is allocated to all of my Lambda functions. Okay, so currently I have 3 Lambda functions, and if all these 3 functions are running as per their schedule and as per their triggers, okay, they will consume this 10 concurrency limit. Okay, so it is very lower limit, but let's say in the production environment, for any enterprise applications, if you have deployed 3 or 4 Lambda functions, okay, and their consumptions are very high as per the load and the as per the load traffic grows on the application. Okay, definitely you would need the higher concurrency limit, and the concurrent executions multiple concurrent executions will be required by the functions. Okay, in that case you would need to increase the concurrency limit. Okay, so in order to increase the concurrency limit, what we have to do, we have to log into the service quota dashboard on AWS console. So we will type here service quota. Okay, we will get the service quota dashboard here. We can select the service AWS Lambda, click on view quota. Okay, so we'll select the concurrent executions. We can see here currently allocated concurrency limit is 10, default is 1000. Okay, so currently it is 10, but by ourselves we can increase it up to 1000 itself. Okay, and even after 1000, if we need to increase the value more, we can create a request here. Okay, we can specify the concurrency limit whatever we need. Okay, and then we can submit the request. Okay, for a smaller concurrency request, okay, AWS support automatically approves that request, but for the larger limit, the request goes to the support team, AWS support team. They assess and analyze the request. Okay, and accordingly they will approve. Okay, so that's the process of increasing the concurrency limit itself. Okay, but one thing keep in mind, increasing the concurrency limit also incur the additional cost. Okay, because and it also provisions the additional resources, okay, in the background in order to meet the required concurrency limit. Okay, so that is chargeable. Okay, so that was about Lambda concurrency limit itself. Okay, so I hope you got it. Like in order to enable the multiple concurrent executions, the concurrency limit is needed. Second point I need to discuss about asynchronous invocation feature. Okay, so on any Lambda function, okay, you can see the option here, asynchronous invocation. Okay, so what is asynchronous invocation? Asynchronous invocation is one of the feature to handle the failed events, right? Failed events through AWS Lambda. Let us consider with an example, like if you have written a Lambda function that will act or that is going to process any event that is being triggered by SQS queue, okay, or any other AWS service. Like, so we are creating a Lambda function and we have set up a trigger, like when any file is uploaded on S3 bucket or any new message appears on SQS queue, okay, and the Lambda function will process those messages. Okay, there will be scenarios like the Lambda function is not able to process any particular message because of certain reasons, like there is some ephemeral storage outage, okay, or there is memory outage, okay, and there is some issue in the business logic what we have written in the Lambda function. Okay, in that case, the Lambda will not be able to process those specific messages, those specific events. So those are failed events. Okay, so how to handle those failed events? So asynchronous invocation is the way to handle those failed events. Okay, so once I click on edit, okay, here the configuration, like when any events are failed to be processed, we can specify here that how long those failed events will be retained with Lambda. Okay, so you can specify the timing here and how many retries Lambda function will make in order to process those failed events. Okay, so the number of retries is maximum 2. Okay, so we can specify the retention time here and number of retries. Even after maximum retries, if the function is not able to process those events, okay, what will happen in that case? We can further configure the Lambda to inform about those failed events to the owner through SNS topic in order to inform via notification, or put the event in SQS queue for later processing by any custom service. Okay, so whatever failed events will be there which Lambda could not process even after maximum retries, okay, so those event details, event object will be pushed to SQS queue. Okay, we have to select the queue here. Okay, then in that queues those messages will be retained, and further we can write the custom service or different service or separate Lambda service also itself that will push those failed events from that SQS queue and will reprocess it again. Okay, so that is all about the asynchronous configuration of Lambda function, okay, in order to handle the failed scenarios. Okay, so that was the second point. Third one is the file system that I need to discuss. Okay, so file system is that, like for any Lambda function in the general configuration you will see, sorry, it has some default allocated resources like 512 MB of memories, okay, 512 MB ephemeral storage, temporary storage, and some timeout is here, execution timeout. Okay, but these ephemeral storage are temporary. Okay, the footprints of the Lambda function sustains within the ephemeral storage only when the function is executing, okay, during the execution time. But once the execution completes, the footprints or the data in the ephemeral storage got erased or got cleared. Okay, if we want to save those logs or those footprints of the Lambda function for later use, okay, we can connect our Lambda function to the file system. Okay, so we can select the file system, okay, here. But in order to connect the Lambda function to the file system, first we need to configure our VPC. Okay, we need to connect our function to the VPC. Like VPC is the virtual private network in which our virtual machines or the EC2 instance have been configured, or other storage resources like ABS or the EFS has been configured there. Okay, so those file system we can connect. Okay, but before that we need to connect our Lambda function to the VPC here. So VPC configuration we can find here, like we can connect our Lambda to the network in which our instances or the storage resources are available. Okay, once we configure the VPC, then after we can connect our Lambda function to the file system, and the file system will be configured for AWS Lambda. Okay, so these are the advanced configurations. Okay, and but we must know about what they are, and what is the purpose of these configurations itself. Okay, yes, and in the general configuration also, one more important thing I need to explain here. We can also increase the timeout. Let's say we have written an Lambda function, and one execution is completing in 5 seconds or 10 seconds. There will maybe some scenario like you are processing some large CSV files or large FTP files there. Okay, and that is going to time. One file processing is taking 10 minutes or 12 minutes of time. Okay, so in that case, if you need to increase the timeout period here of the execution, Lambda execution, so we can add it the timeout period here. Maximum it can be 15 minutes. Okay, so this is about increasing the execution timeout of Lambda function. Okay, that was it. All these 3 points I have covered, like increasing the concurrency limit of AWS Lambda for multiple concurrent executions, and asynchronous invocation to handle the failed events, and connecting Lambda function to the file system. Okay, that was it. And thank you very much for now. For more interesting videos on AWS Lambda or other AWS services, stay connected to the channel. Please like and subscribe the channel for getting the automatic notifications for all future videos that I'm going to plan for AWS services. Okay. Further, I'm in plan to make videos for all other AWS services also, like DynamoDB, Route 53, VPC, EC2 instances. All those topics are in my plan. Okay, I'll prepare the videos. All interesting videos will be there, and you will get all the notifications automatically. Okay, so in order to be updated, please subscribe the channel. And thank you very much for now. Stay connected, stay happy.